Assalamualaikum everyone. Today our group are going to present about one of the most influential figures in quantum chemistry, Niels Bohr, one of the quantum researchers whose contributions laid the foundation for our modern understanding of atomic structure and quantum mechanics. So this is the table of contents and our group members. So for the introduction, Niels Bohr was born on October 7, 1885 in Copenhagen, Denmark and passed away in the same city in 1962. Raised in an academic household, he was strongly influenced by his father, Christian Bohr, a professor of psychology. From a young age, Bohr was immersed in a culture of scientific curiosity, which later fueled his groundbreaking contribution to atomic theory.
Let's talk about Bohr's atomic model. In 1913, Niels Bohr introduced a revolutionary atomic model. He proposed that electrons orbit the nucleus in fixed energy levels, or shells, without losing energy. What made this idea special was that electrons could jump between these levels by absorbing or emitting a specific amount of energy that we call a quantum leap. This explained the previously mysterious line spectrum of hydrogen. Next, Bohr postulate in hydrogen spectrum. Bohr's model was based on two key postulates. First, that electrons move in stable orbits, and second, they release or absorb energy only when they transition between orbits. He applied this to explain the hydrogen spectrum using the equation E equals to H over Nu, where energy is related to light frequency. Next, the legacy in Bohr's model. Bohr's work became the foundation of quantum chemistry. It shaped how we understand atomic bonding, electron shells, and periodic trends. His ideas inspired future quantum models and are still relevant in technologies like spectroscopy and nanoscience today.
From orbits, in these fixed orbits, the angular momentum of the electron in an integral multiple of h over 2 pi, where h represents Planck's constant. Next, therefore, for the angular momentum L of the revolving electron will be L and h over 2 pi, where n represents the integer and h is the Planck's constant. The energy of an electron revolving in a stationary orbit will remain constant, and the energy emitted from an electron from a higher position will jump to an energy of a lower position. When an electron jumps from one energy level to another energy level, it will radiate energy. Limitations of Bohr's atomic model. So, in Bohr's atomic model, it does not approve of Heisenberg's uncertainty principle, and for Zeeman effects, it could not explain using Bohr's atomic model, as the same for Stark effect and electronic spectra generated from the large atoms. For the application of Bohr theory, the model has a significant impacts on setting up the grounds for quantum mechanics in explaining various observations. As for the spectrum of hydrogen and hydrogen-like atoms, they were explained very accurately using this model. The classical physics had so much popularity that the quantum mechanical postulates were not getting attention or importance they deserved. After the explanation, it was hard to avoid quantum mechanics altogether. The Bohr model of hydrogen atom was the first atomic model to successfully explain the radiation spectra for an atomic hydrogen. As for the distribution of electrons in orbits or shells, the electronic distribution of various orbits or energy levels can be calculated by using the formula Qm over 2, where m represents the number of orbits. So here is the calculation for the first K shell, can be calculated by substituting the first orbit into the formula, thus getting the number of orbits, maximum number of orbits will be 2, and continuously as for the other orbits. And here is the representative of the Bohr model. For the era of influence, starting from 1930 until ended in 1962.
Okay, next, major discoveries and theories. In 1930, Bohr proposed that electrons move in a fixed energy level without losing energy. They only emit or absorb energy when they jump between levels, which explained the hydrogen line spectrum using the equation E equal to Hb. He also introduced a planetary atomic model where electrons orbit the nucleus in a specific quantum mass. This explains why atoms are stable and emit discrete light lines and not the continuous one. Next, in 1920, he introduced the correspondence principle linking quantum results with the classical physics at larger scale. In addition, with Heisenberg, he helped develop the covariant interpretation, which says particles have no defined state until measured. It highlights probability and the odds of rule and is still widely accepted today.
Next, I will talk about the legacy and long-term impact. The first one is building modern quantum chemistry. The second one is driving nanotechnology and quantum device. Next, the third one is educational cornerstone. The fourth one is philosophical influence. And the last one is the Niels Bohr Institute.
Next, due to the study of Niels Bohr, there are several modern relevance due to his work that we have achieved. So one of them is quantum dot nanotechnology, which depends on Bohr's idea of quantized energy levels. For the next, it's laser spectroscopy and atomic clocks, which depends on Bohr's explanation about his model. And lastly, electronics and clock readers, which is about Bohr's ideas of energy levels, forms the basis of how semiconductors works.
Therefore, in summary, Niels Bohr's work laid out the framework of quantum mechanics. His contribution in quantum chemistry incorporated quantum theory to an atomic model, creating the first atomic model with quantum mechanics with the concept of quantized energy level. He managed to explain the hydrogen emission spectrum and the problem of atom stability. He has a great impact on his era. By using his atomic model, he started a revolution on quantum mechanics and managed to challenge classical physics by creating Copenhagen interpretation and complementarity principle. He also has a legacy in modern times that uses the concept of quantized energy level in quantum dots in nanotechnology and also electronics and computers. He also uses the concept of electronic jumps that now we use as laser spectroscopy and atomic clock. This is our references. Thank you.